So the first thing we need to do here is we're first going to find the antiderivative. And in order to do that, I need to multiply this out, with good old FOIL. So I'm going to first, outer, inner, last. All right, so I have 2x times 4x squared makes 8x cubed, right? I think so. By the way, there's a little dot here that makes this look more something. I hope I copied down the problem right. Anyway, but 2x times 4x squared makes 8x cubed, then 2x times 1, so a plus 2x. Then negative 3 times 4x squared makes minus 12x squared. Negative 3 times 1 makes negative 3. And sometimes those little things are worthwhile to look at a little bit more carefully, but I think that's it. So now I'll just use the power rule, and I get 8x to the 4th over 4. Where's that coming from? Well, with the power rule, I look at the power that x is raised to, x to the 3rd power. I add 1, which gives 3 plus 1 is 4, and then I divide by that 4. Come to the next one over here, x to the 1 power. Well, what do we do there? I have 2x, and I take 1 plus 1 is 2, and I divide by 2. So I take the power, and I add 1. And then I divide by that result. Then let's just move along. I'll keep color coding. Let's say this x squared. I add 1, you get x cubed divided by 3. And then if I have a constant, that just gives 3x. The derivative of 3x is 3. Well, this is negative 3x. The derivative of negative 3x is negative 3. And so that's what we do with a constant. And then I evaluate from 0 to 2. When I put in 0, there's not going to be, it's just
Can you
going to be
also simplify, like the
yeah, maybe that's a good idea. I'll simplify first before I start plugging everything in. So I'll get 2x to the 4th plus x squared minus 4x cubed minus 3x from 0 to 2. Looks about right. So I have 2 to the 4th plus 2 squared minus 4, 2 to the 3rd minus 3 times 2, all of that minus 0. So 2 to the 4th is 16 times 2 is 32. 2 to the squared is 4, minus 2 to the 3rd is 8 times 4 is 32, minus 6. So hopefully that's not going to, stuff like that is not going to stop us from, getting the right answer. 32 plus 4 is 36. 32 minus 6 is 38. All right, I am sort of concerned about this. Does this make sense that I'm getting a negative answer? Well, 4x squared plus 1 is positive throughout the interval. So if you look at this part, I'll highlight right now, 4x squared plus 1 is positive throughout the interval. Let's check out this one over here, 2x minus 3. Well, 2x minus 3, if I set it equals 0, 2x minus 3 set equals 0 gives x equals 3 halves. And 3 halves is between 0 and 1. So, so what am I getting at? From 0 to 3 halves, like if I put x is 0 into 2x minus 1, I have a negative. And then, so between 0 and 3 halves, 2x minus 3 apparently is negative. But then from 3 halves to 2, it's positive. So it appears there's more negative than there is positive. And what that means is that if you're sketching this graph, it has, well, I mean, I don't know. I don't even want to spend how much time. I mean, we're done with the problem, but I do like to verify that I'm getting this right. So I'm going from 0 to 2, and you can verify that the function is negative. Up to 3 halves, this function is negative, and then after 3 halves, it's positive. So apparently, though, if you're thinking about this, if we're thinking about this in terms of area, the area, I'm not saying that's what the graph looks like, but something. It apparently has an x-intercept at 3 halves. the area that's below the curve is greater than the area above the curve. So that's why we get a negative number there. But that's just a verification. Oh, another easier verification. I just look at the back of the book. Yep, -2 is correct. But if I get a negative number or positive, I look back at the function. Okay, does that make sense for it to be negative or positive? So if the function had been positive throughout the interval, that wouldn't make sense to get a negative integral.